Okay, so multiplication with fractions. And I was thinking about what I wanted to say about this, and the main kind of situation came about. Maybe I think of it in this way. So, like, I made a pan of brownies. Okay, there it is. Right? And my two kids came home and ate a third of the pan, let's say, and left 2/3. Okay, so let's say then this looks like this. Okay, and this is what they ate, because this splits the pan into three equal pieces, right? There's a third, there's a third, and there's a third, right? So there are three equal sized pieces. They ate one piece the size of 1/3. And this is left here, right? Okay, so and in our kind of imagining, we might say that that's shaded in. So what's left is 2/3. Okay, so now the next day, I get home and eat, let's say, a fourth of what's left. Right? Okay, so now really we understand. So here's what's my kids left me, right? And really we understand that I need to split this whole thing, what's left, into 4 pieces and eat one of them, right? So one of the ways that you could do this, so I'm going to split what's left. So here's this 4 pieces, right? That's a fourth of what's left, a fourth of what's left, a fourth of what's left. And I'm going to eat this one. Joanna ate. And what's left in the whole plan is these 1, 2, 3, 4, 5, 6. Now, do you see how I just drew these lines just to the end to show how the 2/3 of the pan gets split into fourths? But if I just keep drawing them, it gives me a better sense of how much of the total pan I ate. So like how much did Joanna eat of the total pan, right? And really this tells me that I ate 2 pieces, and the size of those pieces is 1/12. Because there are these 12 total pieces. So here's a third, a third, right? So there's a 3 by 4. So this has 3 columns, and this has 4 rows. That's where we get this 12, right? Oh, I shouldn't put equal there, but I'm going to show the result of this problem. So 3 by 4 gives me this 12. And in the numerator, it's this array here, which is a 1 by 2 array, which gives me 2/12. Okay. And then I'm going to redraw this because I recognize that I can redraw 212. So the part that I ate now, I'm going to redraw all these pieces. Ugh, these are not the same size. But now I'm going to draw it 2/12 and I want that to look like 1/6. So I don't know how to do that. Interesting. Let's draw these, maybe. So there's 2/12. And then I suppose if I got rid of, have to get rid of some of these. If I get rid of this line right here, and I get rid of this line right there, oh, this line is not in the middle. Then I have 6's, and this should be my 1/6, and I get there by canceling the 2/2. Right? Okay. So, and I think these kind of pictures are what I'm trying to get at. Now, if I'm just doing a normal problem, that is maybe like a story that I would tell about multiplication and how to figure it out. So maybe that's one representation of the meaning of this. So like all of this is, what does the multiplication of fractions mean? Is the question that I'm trying to answer, right? Okay, so another way to do this, let's do another problem. Let's do 3/4 times 2/5. How's that sound? Okay. So, the other way to think about this problem, let's say, is I'm going to draw fourths here. 1, 2, 3/4. And there's 3 of them, right? And so this is a picture of 3/4, and I'm going to maybe draw it up this way. Now, 3/4 also represents the length from here to here. So if you're thinking about it as an area diagram, that's that length. So now if I want to draw the other dimension in fifths, 1, 2, 4, 5. And this 2/5 looks like this, right? And this is right, that length is 2/5 along here. Now if I lay these on top of each other, I get the double shaded picture that we have been talking about. This double shading. So 1, 2, 3, 4. 2, 3, 4, 5. And then here's my 3/4. Here's my 2/5. And then the double shaded part, the result that I think you honestly need to draw, looks like this. Let me see. I'm trying to keep all these the same size. It's possible they're growing in size, I think. So the double shaded one is here, 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 here. So I have to make a conclusion. This is 3/4 times 2/5 should be equal to a 3 by 2 array over a 4 by 5 array, which is 6/20. Right? And there are my 6 pieces, and you can see this part of the thing has 4 columns, and going this direction I have 5 rows, which gives me 20 total pieces. Okay, and again, like this would be a final result, except there's 6 out of 20, so I know that is 3 out of 10. So I think I'll leave all these 5s in here. And then again, I have these 4s, but I'm going to erase this one and this one to get 10 pieces. Oh, that's hard. If I go back, okay, look, Do you see? It's going to be hard for, I'm going to fill in these two, and then I got like this, so I don't have it divided well. So really what I want to do back is go back here and move this one here, and move this guy here. Right? And then I'm going to erase this on my paper so that I can draw it correctly. Okay, so this is 6 out of 20 is equal to 3 out of 10. So 2 times 3 over 2 times 10. Is this okay? Now I can also do this problem. What's the problem? 2/5 times 3/4. Okay, so then I'm also going to do this problem 2/5 times 3/4. And I'm thinking of this as like a length times width problem. So if I draw a rectangle, it has a length, and in this case, the length is 2/5, no 3/4, because I did that way in the previous problem, and this width is 2/5, and the question is, what is the area of this box if I have these two linear dimensions, right? So but it's really hard to figure out what that is. It doesn't rely on whole number mathematics. I would have to know the answer to that problem in order to figure out what it is. So I want to use whole number mathematics to figure this out. So I'm going to draw this box and divide it into 4 pieces so I can picture 3/4. Now the entire length of the box is 1. Oh wait, I can move this down to the bottom because it's kind of in the way. So the entire length of this box is 1. And the entire width of this box is 1, right? But the length that I want is just 3/4. So I'm going to picture that on the box. And I'm going to shade this in. Oh wait, I'm getting ahead of myself. Okay. And then in the other directions, I want to do 2/5 because I just want to do this without the double shading, I think. So it's 2/5, now 3/5. 2/5, I'm going to draw it. Okay. And then I have this length times 2/5. So a rectangle that I draw has like this length. I go from one corner to the other, and this is my box. Do you see that? And that's the rectangle. The area of a rectangle is 2/5 by 3/4. Okay, and these are the same area. It's just that now my second picture lets me figure out what that actual area is, right? I have 6 pieces and they're size 1/20th because there are 20 total pieces in that box. And because this is a 1 by 1 box, I know what the size is relative to something that I know. Okay. So, this is one of the ways that we can picture this, just kind of using linear dimensions of this box, this length times width. So if you look up here, I can also do this by double shading. And the box sizes are the same, but down here I'm really picturing it as a length times width. Okay? And I would need to go back and show kind of how to turn that 6/20 into 3/10. Okay. I want to do one more problem with mixed numbers because that's important. 2 2/3 times 4/5, and I want to do this like someone did it in class. So I'm going to draw. This is very important that I establish what the whole is for this problem. So this is a 1 by 1 square. This is the whole. Okay. So, but then I need to draw the problem, and the problem is bigger than 1, and it's even bigger than 2 holes. It's between 2 and 3 holes. So I'm going to draw 3 boxes that are the same size as my hole. So this is a 3 by 1 rectangle now. Right? Okay. And then I want to represent 2 and 2/3. So there's 1, 2, and then I split this other one up into 2 into thirds. Okay. And the reality is I sometimes will split up. Oh, here, I'm gonna do these in another color so you can see the hole better. But I'm going to split up all of these holes into thirds just to make the math easier, so all of the pieces are the same size and I don't have to kind of convert. Okay, and then I want to picture this 4/5. So I'm going to draw and divide along these rows into 5 rows. Okay. And now I need to picture, I'm going to picture again this length and width in this problem. So there's 1, 2 and 2/3. And then I'm going to picture 4/5 along one side. Good. And now I'm going to draw the rectangle that meets those dimensions. So there's a 4/5. I go to that corner, all the way across to the red line, up, and then back to the original corner. And that rectangle is the 4/5 times 2 and 2/3 rectangle. Right? Okay. So that represents the area that I'm trying to find. Good. So I want to kind of make sure that I know what this result is. So I'm going to come over here and let's see, how many is that? I wanted 2 and 2/3 times 4/5. I'm going to convert 2 and 2/3 into an improper fraction. So the number 2 for sure is 6/3. And I'm going to add that to 2/3 because it's 2 plus 2/3. So I get 8/3 times 4/5, right? So across the top I should have 32 total shaded green squares, or 8 columns times 4 rows. Do y'all see that? And then 15 is the total number of squares in a single box, right? Not in this whole thing, but in this purple box that I have just outlined, right? Okay. So there's 32 over 15 pieces. Okay. So I'm going to maybe redraw this and try and figure out what this fraction is, because 32/15 also is a mixed number, so I need to represent that in my final solution. So I'm going to re-subdivide everything, redraw it, and then I'm going to shade in. Do you see I have 4 rows here? And then I need 3 extra boxes, or 3 extra kind of squares. So I'm going to take them from there and put them down in this final row in my first whole one. And then same thing in the second box. 1, 2, 3, 4. And then 1, 2, 3. Take those. And then that lets me see I have 2 boxes left over right there. So I have 1 and 2. So this is a picture of 2 and 2/15 right there. Okay. So I hope that this has been helpful to you, and that you have a better idea of how to kind of like different ways to think about these problems, or like a story that you could tell. Yeah. So let me know if you have any questions. Oh yeah. It is really important that I establish what the hole is here, because I'm using these connected rectangles. So you definitely need to make sure to do that. Okay. But let me know if you have any questions.